Hello, guys. It's a pleasure to be here with you, even if I'm not at the classroom. So, I'm going to be giving instructions for what you're going to do while I'm gone. I'll be there tomorrow, so I'll be able to explain if you have any questions. So, today we're going to learn about proportional relationships and graphs. A graph shows a proportional relationship if it is a straight line through the origin. A graph shows a non-proportional relationship if it is a non-straight line or if that straight line does not pass through the origin. So we're going to see these two graphs right here. We have two graphs, and we're going to determine if they are proportional or non-proportional. So we just read what a proportional relationship is in a graph and what a non-proportional relationship is in a graph. So if you see here, the origin, it's 0, 0. This right here, okay? So this line starts right here. That means it's the origin. And this graph, the origin is right here. If you see, the graph doesn't pass or doesn't start from the origin. So the first one would be a proportional, right? It will be a proportional relationship because it begins in the origin. This other one would be a non-proportional because it does not begin in the origin. Okay, so that's the first thing we're going to learn today. Let's see how can we apply it. Let's see example number 1. Turn your page over and we'll see example number 1. And in example number 1, it says a rabbit challenges a tortoise to a race. The table shows the distance that the tortoise moved after 0, 1, 2, and 3 minutes. If you see in this table right here, we have the relationship. In 0 minutes, well, the distance traveled was 0. In 1 minute, the distance was 6 feet. 2 minutes, 12 feet. 3 minutes, 18 feet. The first thing we need to do is we need to determine whether the number of feet the tortoise moved is proportional to the number of minutes by graphing the relationship on the coordinate plane. How do we graph when we have a table? So one of them will be X and the other one will be Y in our graph. Okay? Let's see the graph. If we remember, when we move 0, okay, when we have 0 minutes, they advance 0. In 1 minute, right here is the time, the minutes. In 1 minute, the distance was 6. In 2 minutes, the distance was 12. And in 3 minutes, the distance was 18. So this is how we graph it, right? 0 minutes, 0 feet. 1 minute, and we go to feet, 6 feet. Even though we don't have the 6 right here, okay, we can imagine that this graph is going 2 by 2, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. Okay, so that's why we put the point right here in the 6. In 2 minutes, we go up until the 12 feet. And in 3 minutes, we go up until the 18 feet. Now we draw the line. We start from the origin and we draw the line right here, okay, that goes through every single point that we graphed. Okay, so we have a straight line, and if you see, the line begins in the origin. The origin is right here, 0, 0. Okay, so the part A was graph the relationship with the table information, and in part B, we have to describe the relationship. So the line is straight and passes through the origin. So the relationship is proportional. Why or how do we know it's proportional? Because it begins at the origin and it is a straight line. All right, so that's our first example. Let's see example number 2. In example number 2, it says, again, the same thing. A rabbit challenges a tortoise to a race. The table shows the distance that the rabbit moved after 0, 1, 2, and 3 minutes. Determine if the distance the rabbit moves is proportional to the time by graphing the relationship in the coordinate plane. So the first thing we need to do is we need to graph the relationship. In 0 minutes, the distance was 0 feet. So the first point we're going to graph will be exactly right here in the 0, 0. Okay, so we're going to graph it right here in 0, 0. Okay, that first point. The second point will be in 1 minute, the distance was 8 feet. So the first point will be right here. The second one, it says that 2 minutes, 8 feet. In 2 minutes, it also was 8 feet. So in that minute, this tortoise didn't move. In 3 minutes, the distance was 15. So the next point will be right here. Now, what we have to do is we need to graph this line. If you see, we have a line that goes right here, and then it goes right here, and then it goes right here. Part A says graph the relationship. We already did. Part B says describe the relationship. So the relationship between time and distance is not proportional because the graph is not a straight line. Okay, if we see right here, it begins in the origin. So it complies with the first characteristic. But if you see the graph, it's not a straight line. Okay, so that means this is a non-proportional relationship. Okay, good. Now, the second thing we're going to learn is to find the constant of proportionality from graphs. If we have a graph, we can see if the relationship graph it's proportional or not proportional. Now, if you see this graph, it is a proportional relationship because it begins in the origin and it's a straight line. But it's asking what is the constant of proportionality. When a proportional relationship is graphed, like in this case, you can determine the constant of proportionality using any point on the line other than the origin. Remember, the origin is the 0, 0. Okay, that's the origin. So we don't use this point, the first point right here. We can use any other point in the graph. And the constant of proportionality is the ratio of y divided by x for any point on the line except 0, 0. When x it's equal to 1. So write each order pair and write the ratio y over x when x it's equal to 1 for each. Okay, so if you see, we're going to write the relationship of this point right here, the first one. Okay, y it's these numbers right here, and x would be any of these numbers right here, okay, in the horizontal line. So how do we know what number we're going to use? If you see this point right here, I'm going to put it red. If you see it, if we go this way, it is in the 10. And if we go down, it would be in the 2. I'm going to write it with a straight line, 10 and 2. So it means y, the y number, okay, would be the one that is in the y line. And the x number would be the one that it's in the x line. Okay, so in this case, y would be 10. Okay? We have it right there, it's 10. And we're going to divide that 10 by x. In this case, x, it's 2. So when we divide 10 by 2, we get 5. So my constant of proportionality would be 5/1, which is the same as 5. If we do any of the points, the result will be the same, okay, because it's a proportional relationship. So the constant of proportionality of this graph is 5. Let's do an example, so it will be a lot more clear. It says, find the constant of proportionality from graphs. In a 100-meter race, assuming the runner's rate is constant, the distance run is proportional to the time spent running. One runner's data are shown on the graph. Find the constant of proportionality and describe what it means. Part A, find the constant of proportionality. Remember, the ratio y/x, or distance over time, for all the given points are shown. If you see the first one, if we do a straight line, it will be 31 divided by 5. The second one will be 62 divided by 10. And the third one would be 93 divided by 15. And we have them all right here in the bottom. We have the 31 divided by 5, and we have the 62 divided by 10, okay? So when we do the division, we will get the same answer for any point. 31 divided by 5 is 6.2, okay? Divided by 1, which is 6.2. 62 divided by 10 is 6.2 divided by 1. So the constant of proportionality for this example would be 6.2 divided by 1. Part B says, describe the constant of proportionality. How can we describe it? Because the constant of proportionality is 6.2, this means that the runner moves at a rate of 6.2 meters per 1 second. Every second, the runner will move 6.2 meters. Now, the third thing that we're going to learn in this lesson is to analyze points on a graph. When two quantities are proportional, you can use a graph to find the constant of proportionality and to interpret the point 0, 0. Okay, so if we see this example right here, it says the point 1r tells you that the constant of proportionality, or the unit rate, is r. Why r? Remember, when we find the constant of proportionality, is y divided by x. And right here in this graph, in these points are x, comma, y. So what does that mean? When we have any set of points in a parenthesis, like in this case 1 on r, it means that x is 1 and y is r. Why r? Because we don't know the number that we have right here. So the constant of proportionality will be r, because any number divided by 1, it's that same number. Okay. Now, how do we interpret or how do we analyze this 0, 0? So the graph of every proportional relationship passes through the origin 0, 0 and is a straight line. So remember, this is a proportional relationship because it has to go through the 0, 0 points. Let's see an example. Example number 4. It says analyze points on a graph. The number of students on a school trip is proportional to the number of teachers as shown in the graph. The line representing the relationship is a dashed line because the number of teachers can only be a whole number. Okay, so it means that it can only be a whole number. So what do the 0.00 and 125 represent? Let's see. The 0.00 means that for 0 teachers, there are 0 students. Okay, that's what it means. Now, the 0.125 means that for 1 teacher, there are 25 students, right? So we have 25 students for every teacher. This also means that the constant of proportionality is 25, and the unit rate is 25 students for every 1 teacher. If we use any of these points to find the constant of proportionality, we will find out that it will be 25. Let's do it with this one. And this one, it's 104. So remember, we need to put y divided by x, and the y will be the 100. So it will be 100 divided by x. X will be 4. And when we divide 100 by 4, our answer is 25. Okay? Good. Now, to finish this lesson, we're going to do an application. And this will be a fundraising application. And it says, Michelle and Angelo are participating in a school fundraiser. The number of items each student sells after 1, 2, and 3 days is shown in the table. Which order pair represents the unit rate for the number of items sold per day? And it says day 0, 1, 2, 3, and Michelle's number of items is 0369, and Angelo's number of items is 0145. So what do we have to do? We need to find which of these order pair represents a unit rate for the number of items sold per day. In day number 1, we sold 4 items. In day number 2, we sold 10 items. And in number 3, we sold 14 items, right? So how do we do it? The first thing we need to do is to find out if the lines for these tables, for this data, will be a proportional or non-proportional relationship line. If we see Michelle's line, in 0 is 0, in 1 is 3, in 2 should be 6, in 3 should be 9. If we see Angelo's, 1 is 1, but 2 it's 4, and 3 is 5. So it does not grow in a proportional relationship. So that means that we're going to use Michelle numbers. And remember, the unit rate, it's for each day, how much they sold. So right here we have the answer. In 1 day, Michelle sold 3, right? 3 items. So this is really, really easy because it will be the constant of proportionality is 3. Because if we graph it, we're going to graph in 1 day, she sold 3 items. And when we divide 3 by 1, our answer will be 3. So this will be the pair that represents the unit rate for the number of items sold. So when you do the check, first find out which of the lines will be a proportional relationship line. And when you find it, find out for one thing how much would be of the other one. That is the unit rate. For every unit, how much would it change? Okay. Well, so this would be it. This is the lesson. Please go ahead and fill every single example in your book and do every check. And I'm going to be checking this with you tomorrow. All right. Thank you for everything. And I hope you have a wonderful day.